All right, functions, we are, this is where we ended yesterday, so I would like to move on. So we're going to try multiplying. Here are some examples. If you did not get this in your notes, go ahead and get this in your notes now. So hit pause, put this in your notes. Okay, so we have the first example, and we're going to want to multiply these rationals. So something that I like to do, let's see if I can. Something that I like to do is I like to put parentheses around this. I like to put parentheses, sorry, I was choking on a Cheeto. I like to put parentheses around this because it's going to remind me later on that we are multiplying. Because if I do it like this, and I make it all one big fraction, now it's just a simplifying problem. I mean, I still have to factor. I still got some work to do, but I can simplify. So if we look at this one, this looks like I'm going to need to factor this. I'm going to need to factor this. I'm going to need to factor this, and I'm going to need to factor this. So this factors, this is a GCF. This factors, I'm going to use box and diamond to factor that. This is a difference of squares. And this is another GCF. So if I'm looking at that. So go ahead, and I'd like you to hit pause right now and go ahead and factor all of those. So this is, again, right where I say, when in doubt, factor it out. So when you're in doubt, factor it out. So if you don't know where to start factoring. Just factor what you can factor. So go ahead and hit pause and factor. All right, so I factored all of these out. The first one was a GCF, and I was able to factor out a C, and I get C times C plus 2. And then, so I've already made this all one big fraction, so I'm going to go ahead and write that in here, like that. Now what I'm going to do, so since I have all my factors, I'm going to go through and I'm going to find where is the same thing. So I literally start in the beginning of the numerator, and I do this every single time, because as we get into more complicated things, it's just easier to start in the same place and kind of do the same thing every time. So I'm going to look for the first factor. That's a C. I'm going to go down in the denominator and say, oh, nope, this doesn't match. This doesn't match. Oh, but this does. So there's my first big one. And then I'm going to start with the next factor, C plus 2. Oh, do I have another? I do. I have a C plus 2 right there. So that's a 1. And then I'm going to look, let's see, C minus 2 right there. And I have another 1. So I have 1 over 1, 1 over 1, 1 over 1 times C minus 2 over C minus 1, which gives me just C minus 2 over C minus 1. You can either leave it in parentheses or not. It's totally up to you. But that is the final answer. So again, we're going to do the same thing for B. And I like to do it like this. Make it all multiplication first. Okay, now I have all just one big fraction, and I can factor this. This is going to be difference of squares. I can't factor this one. This doesn't factor, and neither does that. So I'm going to go ahead and factor what I can. So with the difference of squares, and then again, I'm going to look for an m plus 4, excuse me, an m minus 4, and I do like to keep parentheses here. So I don't see one. No. An m plus 4. Yep, right there. So that's a 1. And then I just multiply what's left. So 1 times m minus 4 is m minus 4. And 1 times m plus 2 is m plus 2. So I just end up with m minus 4 over m plus 2. And those are my final answers. That's it. Okay, multiplying is the best. Top times top equals top. Bottom times bottom equals bottom. Now we're going to do division. Now with division, we're going to want to turn it into multiplication. So what we're going to do is we are going to divide rational expressions. So to divide a rational expression, you're going to divide the rational expression by multiplying by the reciprocal. The reciprocal. This is what you've heard before. It is keep the first one the same, change the sign, and flip. Multiply by the reciprocal. Keep, change, flip. That's what that means. In math terms, you're multiplying by the reciprocal. If you need help to visualize it, you're keeping the first fraction the same. You're changing it to multiplication. Then you're flipping it. You're turning it into reciprocal. And that's where the numerator becomes the denominator becomes the numerator. In the second fraction only. So that can look something like this. You could have x plus 3 over 4 And then we could say divided by x plus 3 divided by 4. Okay, so if we do that, that would be rewritten as keep the first one the same, change the sign to multiplication. That bar right there means divided by, keep it the same, and then flip the second fraction, x plus 3. And then it's just a multiplication problem. We could deal with that. So let's go ahead and try it. So in this first one, we've got 5p plus 2 over 6 divided by 15p plus 6 over 5. So the first thing we want to do with division is we want to turn it into multiplication, so it's an easier problem. So we're going to keep, now I've got some fancy stuff here. We're going to keep the first one the same. We're going to change that sign to multiplication, and we're going to flip the fraction. So we went ahead and flipped it. Now it's just multiplication. And again, I like to keep things in parentheses. These are pictures from the book, so it's not written that way, but that's the way I would do it. It would be like this. And then I'm going to factor where I can factor. 5p plus 2 does not factor. 5 is just a prime number, so it doesn't factor. 3 does factor, or I'm sorry, 6 does factor into 2 and 3, or yeah, 2 and 3, but I'm going to go ahead and leave it alone. And 15p plus 6 does factor. I can factor out of 3. So we are going to factor. All right, so once I factor, I find the big ones. So whatever is exactly the same on the top and the bottom. And then this is why I like parentheses. So I'm left with a 5 here, a 6 here, and a 3 here. But I'm multiplying. So 1 times 5 is 5, but 6 times 3 is 18. So I am left with 5 over 18. All right, so now we're going to do the second problem. And this one's a little bit weird. So the first thing we want to do is turn it into multiplication. So we are going to keep the first one the same. We're going to change it. And then we're going to flip. Boom. Keep, change, flip. All right, now I'm going to put everything in parentheses. So we're going to talk about how to factor. There's a couple different ways to do this problem. I'm going to show you the way that I would do it so that there aren't any mistakes. But there might be, because we learned a rule yesterday. So the first thing I would do is I'm going to see that this is a GCF. This is a GCF. I can't factor this one, and this is a difference of squares. So this 4, so 4 minus q squared is a difference of square. 4 is a perfect square, and q squared is a perfect square. So this is going to factor as 2 minus q and 2 plus q. Okay? That's fine, and we can do it that way. So here, I will do this whole problem that way. So we're going to end up with q times q plus 2 times, let's see, 3 times q minus 2 all over, okay, 5 plus q doesn't factor. And then I have it already factored right there, so I'm going to have 2 minus q and 2 plus q. Okay, so we have this q, no other q's by themselves, but we have a q plus 2, and this 2, positive 2, positive 2, positive q, positive q. This and this are exactly the same. Now, we have this 3, there are no other 3's, but then we have a q minus 2 and a 2 minus q. And yesterday we learned that if we have a q opposite, 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 so if these two things are the exact opposite, they turn into a negative one. So this and negative 1, right? So a negative, it would be like a negative big 1. So we're going to have this negative 1. Now when we factor, we're going to get q times 3, that's what's left, so 3q, over 5q plus 5 plus q times negative 1, which would be negative 5 plus q, or q plus 5. And we can never have a negative in the denominator, so it's really going to equal negative 3q over, I'm going to rewrite it q plus 5. Okay? So that's one way to do it. And that way will work. But let's go ahead and erase what I've done. So let's see. I'm going to hit pause and I'll be right back. So another thing that I can do is that I can recognize that the q here, I'm going to have a q plus 2 and a q minus 2. I'm going to have positive q's, and to get a positive q, I can actually factor out a negative 1. Let's see if I can get my... There we go. Factor out a negative 1. So when I factor out the negative 1, I get negative q, or negative 1 times q squared is negative q, and negative 1 times negative 4 is positive 4. So these two things are equivalent, but I know how to factor q squared minus 4 with positive q's. So then I end up with q, and again, I like those. Let me see if I can get rid of the eraser. Let's keep it red again. So I'm going to put parentheses around this. Oops. Parentheses. And then I already have them here. So now I'm going to find my big ones. And then again, just like before, those q's are not going to go. There's no other q by itself on the bottom. But there is a q plus 2. There are no 3 on the bottom. So there are no 3's. That's not 3. That's not 3. So, but there is a q minus 2. I have a 1, but I see the negative 1 out here, so I end up with 3q times negative 1 times that. And again, I can't have that negative in the denominator. So we never want something other than a positive number in the denominator. So a positive divided by a negative is always a negative, so I can put it out front. I can also put it here in front of the numerator, but that's why you want to do that. If we have a negative divided by a negative, then we need to simplify that. We need to find those big ones of negative 1 over negative 1, which is 1, and make it a positive fraction. All right, so this is where we ended. You now will be able to do all of part 1. If you have any questions, please let me know. And otherwise, I hope you have a great weekend.